Okay, so you guys are going to turn to this where we did the acids and bases on Friday, and we are going to go down and do reaction rates, which is actually the chapter we just had a test on. So the first thing I'm going to do is draw in my two graphs. So there's graph number 1, and I'm going to say that this is H2 and N2, and that at the end I have NH3. And then I'm going to draw in my second graph, and we're going to say that KCl is at the beginning, and then we're going to have K plus and Cl minus at the end. K plus 1. Okay. So first, I'm going to go ahead and label that this is my reactant right here, and this is my products right here. Now, this standard says students know the rate of a reaction is the decrease of concentration of reactants and the increase in concentration of products over time. So, when you have a reaction, and I said I would update that and I didn't, so remind me to give you a point. So when you have a chemical reaction, you have your reactants, and these guys are going to stop becoming H2 and N2, and they're going to start making NH3. So as time goes by, 1 minute, 2 minute, 3 minute, 4 minute, 5 minute, 6 minute, 7 minute, 8 minute, 9 minute, 10 minute, as 10 minutes go by, you're not going to have any more of the reactants because they have become the products. So as time goes by, so decreasing with time is going to be our reactants. We're getting less of these as time goes by. So H2 and N2, they decrease in amount as time goes by. They decrease in concentration. Okay, right, reactants. And then increase with time, those are going to be my products because that's what I'm making. So as the chemical reaction is happening, I'm getting more and more of my product and less of my reactant. I can do the same thing over here. Which ones increase as time goes by? Well, these are my reactants at the beginning, and these are my products at the end. And as time goes by, 1 minute, 2 minute, 3 minute, 4 minute, 5 minute, 6 minute, 7 minute, 8 minute. As time goes by, I am getting more products. So they are increasing as the reaction happens. They're increasing with time. So that's me K plus 1 and Cl minus 1, or I could say product. And decreasing with time is going to be my reactants. And the reason is because as time goes by, we're not getting as many Ks and Cls together. They're breaking apart to give us the product. So we're getting less and less KCl. Or I could say reactant. Okay? So moving on, label which concentrations will increase with time and which concentrations will decrease with time for the reactions. So these are my reactants and these are my products. Now, this doesn't have to do with equilibrium. Notice this is definitely a forward reaction. So as time goes by, as the reaction's happening, I am going towards my products. That means as time goes by, I'm getting more of my product. And if I'm getting more of my product, that means I'm getting less of my reactant. So less Na and less I2. Same thing here. This is not at equilibrium. Notice it's just the forward reaction. So these are my products, and on the left is my reactants. As the reaction's happening, as it's progressing from left to right, I'm getting more of my product. Okay, it's being made. So I'm getting more carbon dioxide and more water. And at the same time, if I'm getting more of my product, that means I'm getting less of my reactant. So oxygen is going down and C3H8 is also going down. Moving on down below here, it says students know how reaction rates depend on such factors as concentration, temperature, and pressure. So what we're going to write down now, hopefully, is all review. You know that if you increase temperature, that gives you increased collisions, and that gives you an increased rate. Pressure, same thing. If you increase pressure, that gives you increased collisions, and that gives you an increased rate. Okay? The reaction goes faster. Same thing with concentration. If you increase concentration, now increased concentration, that means that you have more particles. So it's like maybe you only had a teaspoon of sugar inside a cup, and instead of a teaspoon, you increased the concentration and you added a whole cup of sugar. That would be lots more particles. And that means you would have lots more collisions, so increased collisions, and that would equal an increased reaction rate, or the reaction is going to speed up. Flipping the page. So, oh, wait a minute, where did my reaction go? Oh, I don't need a reaction for this. What will happen to the rate of a chemical reaction if temperature goes down? That equals decreased collisions. That equals a decreased rate. Let me zoom in for you guys. Concentration of reactants increases. If I increase concentration, that equals increased collisions, which equals increased rate. So if volume increases, anything PTV, if volume's going up, pressure is going down. Okay? So you decrease pressure, that gives you decreased collisions, which equals a decreased rate. All of this should be reviewed right now. Pressure increases. If pressure increases, that gives you increased collisions, which gives you an increased rate. The reaction's going to speed up. If temperature goes down, that equals decreased collisions, and that equals a decreased rate. Last but not least, if concentration of reactants decreases, decreased concentration equals a decrease in particles, which equals decreased collisions, which equals a decreased rate. So everything I just did should be, you should recognize all of this. Next up, 8C, students know the role a catalyst plays in increasing the rate of a reaction. So I'm going to draw in my graph that I'm going to use. And you know what? Let's just draw in what a catalyst does. You know a catalyst lowers the activation energy. That's how it speeds up the rate. So I am just going to draw in like so. That's what a catalyst does. I'm going to point to it, and I'm going to say lowers the activation energy. Moving on, 9A, students know how to use Le Chatelier's principle to figure out which way it's going to shift. So I am going to go through this, just getting my reactants and my products. I'm going to do this quickly. So if I add heat, heat's a product, it shifts to the left. If I remove HCl, it shifts to the left. If I add NH4Cl, that is a solid, no change. Add a catalyst, no change to the equilibrium. Add NH3, it shifts to the right. Add HCl, shifts to the right. Remove NH3, shift to the left. Then what I'm going to do is I'm going to zoom in so you can see better. And I am going to indicate that this is the right side and this is the left side. If I shift to the left, the stuff on the left goes up. Oh man, I need to change this. So cross this out and make this HCl. And cross HCl out and make that NH4Cl. Man, I knew there was some worksheet that had them mixed up. I guess this is the one. So if I shift to the left, NH3 and HCl are increasing, and that means the stuff on the right is going down. If I shift to the left, that means the stuff on the left goes up, so NH3 and HCl go up, and the stuff on the right goes down. No change for these, so I just go all the way across like this. When I shift to the right, the stuff on the right goes up, so NH4Cl goes up, and the stuff on the left therefore goes down. When I shift to the right, the stuff on the right goes up, the stuff on the left goes down, and if I shift to the left, the stuff on the left is what goes up, and the stuff on the right is what goes down. Let's check time. Okay, so let's look at this one. So, I forgot to do the equilibrium arrow. I'm going to draw that in. So, delta H is positive. That means that this reaction is endothermic, so heat is a reactant. So I'm going to go ahead and add heat to the reactant side. State whether the forward or reverse reaction is favored. That's easy enough. So if I increase heat, that is the forward. If I add Cl2, that is the forward. If I remove O2, that also favors the forward. Okay? We don't have a rule for volume. We have to think PTV. So if volume goes down, pressure goes up. If pressure goes up, it goes to the side with the less moles of gas. So I look, there are 4 moles of gas on the reactant side, and there are 5 moles of gas on the product side. 4 is the less number, so it's going to shift to the left towards the 4. Oops, can't see. So shift to the left. Next up, 9b, students know how equilibrium is established when the forward and reverse reaction rates are equal. And what we are going to write there is, hold on, I'm checking, what was I saying for this? I had a great thing. Oh, super simple. We're just going to write equilibrium. That just means the forward rate, that's the speed, equals the reverse rate. Remember, rate, that's just the speed. Okay? Equilibrium means balanced and equal. Forward and reverse, nice and equal. Flipping the page. Oh, don't have that ready.